Now, one of the most common tasks that you'll need to do with your skills of finding the derivative is to find the equation of either the tangent or the normal to the curve at a particular point. Tangent lines we've seen before. A tangent is a straight line that touches the curve at a particular point and has a gradient equal to the gradient of the curve at that point. Here's a cubic equation, and if we look at the tangent at the point x equals 1, we can see that the straight line touches the curve here. And if we zoom in, we can see that the gradient matches perfectly. Let's zoom out again, and now we're going to have a look at the effect of moving point P. So at the moment x is equal to 1, and all the way back here, now let's press play and we'll see what happens as point P moves across the curve. The tangent moves appropriately, always touching the curve with the gradient equal to the curve. Now it's time to discuss a normal line. A normal to a curve is similar to a tangent to a curve, except that it's perpendicular to the curve at the point that it touches. You can think of this as being perpendicular to the tangent line, if you wish. Here we can see the normal and the tangent at the same place, and notice that they meet at right angles. At this other point, notice that the same thing happens. Now if we hide the tangent and just look at the normal, this is what it looks like as we change point P. So how do we find the equation of the normal? Well, let's look at a more simple function. Here's the function y is equal to x squared. If we wanted to find the equation of the tangent at x equals 3, we find the x and y coordinates of the point, we find the gradient of that point through the derivative, and we plug those into the equation that you should know, y minus y1 equals m lots of x minus x1. Or you can plug it into y equals mx plus c and rearrange to calculate c and get the equation from there. We're still going to do that same thing for finding the equation of the normal. And since we're talking about a point that is not moving, the x and y coordinates will obviously not change, but the gradient will. So if our m value is different, what is it now? Well, you may remember that the gradients of two perpendicular lines are negative reciprocals of each other. That is, if one has a gradient of m, then the other one has a gradient of negative 1 over m. I'm not going to explain the reason for that in this video, but it's not too difficult for you to prove if you're interested. So at x equals 3, to find the gradient of the normal, we need to first find the gradient of the tangent. The derivative of x squared is 2x, so at x equals 3, the derivative is 6. Thus, the gradient of the normal, and I'm going to write this as m with a subscript n underneath it, is equal to negative 1 over the derivative of the tangent, which is negative 1 over 6. I'm going to plug that value of m along with x equals 3 and y equals 9 into this equation, and as a result I get y minus 9 equals negative 1/6 of x minus 3. Now I'm going to get rid of this 9 from that side and put it onto the other, as well as expand the brackets at the same time. Negative 1 over 6x plus a half plus 9, which simplifies to negative 1 over 6x plus 9.5. That there is my final answer for the equation of the normal to the curve x squared at the point x equals 3. I'm going to do one more example as quickly as I can without explaining things along the way as I go, just to show you the sort of communication that you'll need to write down in a test or an exam situation. I'm also going to do this example without any diagrams. Usually sketching a graph can help explain things, or in a test situation, if you're stuck, it can help you get your head around what the question might be asking and help put it in that context. But it's not always necessary, and for a relatively simple one, we should be able to go through the process for finding the tangent without ever sketching the graph or considering where it might be. So let's have a look at something like that. Let's have a look at the function f of x is equal to 2 over x, and our challenge is to find the equation of the normal at x equals negative 2. So the first thing I'm going to do is plug negative 2 in as x. That gives me 2 over negative 2, which simplifies to negative 1. That's my y value, essentially. Let's also find the derivative of x. so that we can plug -2 into that. However, this needs some rearrangement. Let's remember that we need to turn this into 2 lots of x to the -1 first. Thus, we can bring the power down and then subtract 1 from the power, and the derivative turns into -2 lots of x to the -2, which is equal to -2 over x squared. Now I have to plug -2 into that derivative. That gives me -2 over -2 squared. Remembering my powers properly, the negative is inside the brackets, and I'm going to be squaring that to get +4. So that gives me -2 over 4, which is equal to -1/2. So that's the gradient of my tangent. However, we can also remember that the gradient of the normal is equal to -1 over -1/2, which gives me an answer of 2. So now I need to plug the x value, the y value, and the gradient value into y minus y1 equals m lots of x minus x1. And that gives me y minus -1 is equal to 2 lots of x minus -2. Thus, y plus 1 is equal to 2x plus 4. Y is equal to 2x plus 3. And that's the equation of my normal. So that's the final answer, and I can finish there. But before I finish the video, let's actually type that into Desmos and double check that it makes sense in the context of the graph. This here is the function of y is equal to 2 over x. And if I turn on my normal going through the point -2, or -1, we can clearly see that it looks like this graph does have a gradient of 2 squares up for every 1 square across, and it's got a y-intercept of 3. So this is the line y is equal to 2x plus 3.